Hello students, this is our fourth session of chapter 4 data structure. So in the previous session we have traced some of the arrays using binary search. So in this session let's start with another array, that is tracing of array using binary search. So this is our array. The array contains 10, 20, 30, 35, 40, 45, 50, 55 and 60 as its elements. So here the search element is 35. So here our search element is 35. So what we have to do first, while doing tracing using binary search, first we have to check whether the elements are in sorted order or not. In the next step, we have to mark down the beginning as well as the end. So here this is our beginning and this is our end. So beginning is equal to 0, end is equal to 8. How to find the middle term? If while beginning is less than end, so we have to find the middle term. So how to find the middle term? Middle term is equal to beginning plus end by 2, which is nothing but 0 plus 8 by 2, that is 4. So here 4 is our middle element. Compare the elements of the position 4 with the search element. So 40 does not equal to 35. 40 does not equal to 35. So we have to check whether the search element is less than the middle element or greater than the middle element. If the search element is less than the middle element, then we have to search the element towards the left of the array, or we have to search towards the right side of the array. So check. So 35 is less than the middle element 40. Hence we have to search towards the left of the array. We have to search towards the left of the array. So our beginning is 0. So if the search element is less than the middle element, then the end becomes m minus 1. So E is nothing but m minus 1. What is m minus 1? M minus 1, that is 4 minus 1 is 3. So 3 is our end position. Next, find the middle position. So how to find the middle position? 0 plus 3 by 2, that is 1.5. So consider 1 as middle element. So check whether 20 is equal to 35. 20 does not equal to 35. 20 does not equal to 35. The search element is greater than the middle element. Hence what we have to do? We have to search towards the right of the array. Search towards the right side of the array. So 10, 20, 30, 35, 40, 45, 50, 55 and 60. if the search element is greater than the middle element, then beginning is equal to m plus 1. Beginning is equal to m plus 1. What is the m here? M is 1. What is m plus 1? M plus 1 is 1 plus 1, which is nothing but 2. So here 2 is our second position, is our beginning position. Next, what is the end position? End position is 3. E is equal to 3. So what is the middle position? M is equal to 2 plus 3 by 2, which is nothing but 2.5. So consider second position as the middle element. So compare 30 with 35. 30 does not equal to 35. The search element is greater than the middle element. Hence, we have to search towards the right side of an array. (50), 55 and 60. So if the search element is greater than the middle element, what we have to do? The beginning is equal to m plus 1. B becomes m plus 1. What is m here? M is 2. 2 plus 1 is 3. 2 plus 1 is 3. So 3 is our beginning and end is our third position itself is our end position. So how to find the middle element? That is m is equal to 3 plus 3 by 2. That is 6 by 2. That is 3. So 3 is our middle position also. So compare the element with the search element. 35 is equal to 35. Hence the search element (35) is present in location 3. Location 3. So this is how we have to trace an array using binary search. Now let's write an algorithm for binary search. Algorithm. Let A is the sorted array. B is the beginning. E is the end position and M is the middle position. M is the middle position. So what is the first step? The first step, we have to set B as 0 and E as n minus 1. In step 2, check while B is less than E, we have to find the middle element. So, M is equal to B plus E by 2. B plus E by 2. If element is equal to A of mid, if element is equal to A of mid, then location is equal to mid. If the element is equal to the middle element, then the location is equal to middle element. Go to else if element is less than A of mid, if element is less than A of mid, what we have to do? End is equal to mid minus 1. End is equal to so here M represents mid position. M minus 1, else beginning is equal to M plus end of while. End of while. In step 3, if location is greater than is equal to 0, we have to print the location. We have to print location, else we have to print it as search is unsuccessful. Search is unsuccessful. Step 4, exit. Step 4, exit. So this is the binary search algorithm. Now write a program for this algorithm. Yes, the first step is we have to write the header files. C++ program. #include iostream.h contains C++ stream and IO routines. It contains C++ streams and IO routines. #include conio.h contains functions for console input output. It contains functions for console input output. #include iomanip.h is used for creating parameterized manipulations. Parameterized manipulations, that is for the usage of setW or endl in the function. Next is create a class. Class called search. Class called search. Class called search. Declare the required variables in the private section. While writing private and public, the first letter should be in a small letter. First letter should be a small letter. Private. So int A of 10, that is sorted array, element, n and location. In the public section, declare the functions. Void get data. Get data is used to accept the data from the user. Get data function is used to accept the data from the user. Next is void put data. Put data function is used to display the data on the monitor. Next is void compute function is used for calculations. And end the class by closing the flower bracket with semicolon. Void search scope resolution operator, then write the function name get data function. So cout statement is used to display the data on the monitor. Cout enter array size. So cin is used to accept the value from the user. So cin n. Next, enter the array elements. Using for loop, we are going to accept the elements from the user. For I is equal to 0, I less than n, I plus plus. Cin A of I. Next, we have to enter the search element. So enter the search element. Cin element. Next we have to write the compute function for the calculations. Void search compute function. So here we have to declare the variables like int, beginning, end and mid. Next, set location is equal to -1, beginning is equal to 0, end is equal to n minus 1. While beginning is less than equal to end, we have to find the middle element. Mid is equal to beginning plus end by 2. If element is equal to A of mid, then location is equal to mid break, else if element is less than A of mid, what we have to do? That is end position is mid minus 1. Else else beginning is equal to mid plus 1. Next we have to use the display function to display the location of the element. If location is greater than is equal to 0, element is equal to found in position. Else Cout element is not found. Next we have to write the main function. Void main. So here we are going to create an object, that is search. Yes. Clear screen. Yes dot. So using the objects we are going to call the functions. S dot get data. S dot compute. S dot display or put data. Put data. So this is the program for binary search. Thank you.